Question number 13 DC circuits is an external resistance R is connected to a cell of internal resistance small r. The maximum current flows in the external resistance when option A capital R is less than R, option B capital R is greater than small r, option C capital R is equals to R, and option D any other value of capital R. This is the circuit diagram and we assume current direction to be in clockwise. From Ohm's law we know that V is equals to IR, current into resistance. We need to find current, so we will write I is equals to V over capital R. In our situation, our R equivalent is small r plus capital R. Why so? Because both the resistances are connected in series. We call this equation as equation number 1. We know that when maximum power is delivered, when current is maximum. So now we will use the formula of power. We know power is equals to I square into R. We put the value of current calculated in equation number 1. Put the value of I, V over R whole square into R. We call this equation as equation number 2. And now we will differentiate this equation with respect to our variable R, capital R. Now V square is a constant, we write it outside the bracket and inside we have capital R over capital R plus small r whole square dr. We have to find this derivation. We will use here the division derivative formula. U over V whole dash is equals to uv dash minus u dash v over v square. Now let us write our u and v dash. Our u is r and v is r plus r whole square. U dash will be equals to 1 because this is our variable, and v dash is equals to 2 into r plus r. Because here we are going to use the power derivative formula, d over dx over x plus 1 whole to the power n is equals to n into x plus 1 raised to the power n minus 1 into the derivative of x plus 1, which will be derivative of x is 1 and derivative of constant s is 0. So we obtain 2 into capital R plus R. Power is 2 minus 1 equals to 1. We call this equation as equation number 3. These are our values that we have calculated. Now we will put these values in our formula to find the derivative. V square is constant, it will come outside the bracket, and inside the bracket we have R into 2 into R plus 1, which is V dash minus, now U dash into V. U dash is 1 and V is capital R plus R whole square. We will equate it equals to 0. We forgot here the denominator, which is V square. Here V square is R plus R whole square, and the whole square V square and R plus R raised to the power 4 will be equals to 0 when taken towards the other side. So we are left with 2 into capital R into R plus small r minus capital R plus small r whole square is equals to 0. Take capital R plus small r common from both these terms, and inside we have 2 into capital R minus capital R plus R is equals to 0. Capital R plus small r will be 0 when multiplied by 0 and taken towards the other side. After solving, we obtain capital R is equals to small r, which means that maximum current will flow in that circuit when external resistance is equals to internal resistance.